Quick introductions. I'm Owen Packard, a French guy nearby Paris, leading the product activities at Traefik Labs, and I'm joined by my colleague Emmanuel Fodor, the product manager, and he will do a demo for us today. So first, a few words on who we are. So we're Traefik Labs. Most of you may know us through Traefik Proxy, open source offering. So one of the leading open source ingress controllers with over 3 billion downloads, 45,000 GitHub stars, hundreds of contributors, used around the globe for years, from home labs to super large deployments as a very large company. In terms of the offering, we've got Traefik Enterprise, so the commercial version of Traefik Proxy, doing ingress and getaway. And then the focus of today, in terms of how we make it real, the GitOps approach, Traefik Hub. So Traefik Hub is a modern API management solution, which is completely GitOps driven and Kubernetes native. More on that soon. So a few words about the context. How did we came to focus on APIs at Traefik Labs? Most of the discussion stems from community discussions where so many people loved the dynamicity, ease of use, modern aspect of our open source offering, and said, please guys, bring that to the API world. So we had a closer look, and obviously we all know that APIs is a red hot topic, driven by many aspects. Obviously the cloud native with the machine-to-machine communication ramping up like crazy. We're all seeing the rise of AI driving way more API use. And overall, it's just a modern way that makes sense to build more app and services faster by interconnecting existing systems and making the best out of existing data. And what I heard from many people in our community was, well, you know, with the traditional approaches of API managements we know of and we use today, they tend to be slow and not optimal when it comes to efficiency. They were either heavily based on UI points and click operations or proprietary scripting to configure, deploy, manage everything. And that, according to them, often led to suboptimal release times, not being as speedy innovations as they hoped, and sometimes faulty deployments. So in a nutshell, the API growth is red hot, and governing all that ecosystem is hard, and there could be better ways. So why was that such a problem? In my discussion back then, it came mostly, but not only obviously, from large teams spread around the globe, and the collaboration aspect was hard. Once again, clicking through UIs, proprietary script, proprietary approaches and configuration, spread across many teams, collaborating under one roof is tough. And that resulted in sometimes not fully up-to-date APIs and their documentation that can lead to zombie APIs, zombie portals, and stuff like that. So we had a quick look at how existing solution approach it, what was their philosophy. And I quickly realized that most, not all, but most API management solutions were 10 plus years old, and that predates even the Docker and especially the Kubernetes era. And they were not optimal for modern environments, even though they try to adapt to it quickly. And that comes from the approach, the philosophy. So they were built at a time where everything was designed to be procedural and stateful. So you described do step one, step two, step three. As we said before, most of the operations were performed through UI clicks and proprietary scripting. That leads more often than not with a steep learning curve. So kind of hard to onboard new team members with serious training needed quite often. And as we said briefly, some difficult collaboration, especially at scale. So the net result in these discussions where we have a hard time having a fully and always up-to-date central view of what my current APIs are, how they're configured, how they're used, are they healthy? Not to mention when we have audits, we need to keep track of everything, what happens, when, why, by whom. And again, back to outdated configurations leading to zombie portals or out of date documentation that impact the developer experience. So there must be a better way. And when I stepped back and looking at the problems of collaboration, the standard source of truth, I said, well, hold on, guys. Other teams faced very similar challenges in other domains, and they came up with solutions which are proven and effective. And these teams were the apps, well, the infra apps and services teams, and their answer was GitOps, right? So the idea was, well, wouldn't it make sense to reuse those approaches and tooling which are proven and effective and just extend them to API operations? So, oops. So just a quick word on that, because it's not only about GitOps, it's about the philosophy of rebooting API management. So we drove from some principles, so I can name a few. For instance, the Unix or Kubernetes principle, or the API unbundling you've heard of, which is basically do one thing, but do it well. The other one was a conclusion to that, a consequence of that was, okay, what is the one thing we focus on and do it well? For us, the answer was the API run. So we don't cover the full life cycle. We don't focus on the API creation, design, testing, mockup. We start when you have some services somewhere, anywhere, implementing the APIs, behind the APIs, and we start with a specification. So you give us, okay, this is my API specification, this is my implementation over here in Kubernetes or over there in the VM. Please make it so that people can see it, use it, understand it, and let me track it. The way we do it, based on Traefik proxy, but open to other ingress controllers, is to be very lightweight and composable. So we said our goal is not to invent the wheel. If you are used to some approaches, the idea is to reuse these approaches. And back to the Kubernetes principle, we just do one thing well, but we're pluggable. We can be composed with other parts of your tooling, and so that people can reuse their standard tooling, right? And the high-level philosophy against procedural and UI clicks was to be declarative, and we can talk about that, and to enable collaboration and leverage Git as a single source of truth. So let's have a closer look at the GitOps principles as were declared on the open gitops.dev, if I remember correctly. So the four pillars are: first, it needs to be declarative. It means that if I take an example of a GPS, in a procedural approach, you would say, hey, you want to go to this city, then take this road, turn right, turn left, with all the steps to achieve your destination. The declarative approach, you just say, I want to go there, figure out a way. And that's where Kubernetes kicks in and figure out the way to achieve what is asked, what is declared. And that is a key approach because it unlocks collaboration and enables automated checks, we're going to see later. Why? Because in the declarative approach, you have a human-readable textual file which is so short and to the point. Anyone can read, understand, and collaborate on, okay? And then for the checks, we're going to talk about some approaches, but then you can say, you declare it this way, you declare it that way, there's conflict, there's no conflict. The second key aspect is it is versions and immutable, meaning when you have a configuration declared in Git, and you make a change, then you will have a new version, let's say 1.1 stored internally, and you cannot change the 1.0. So guess what? For all the auditability questions, it's super clear and it's super easy. And then you can reproduce that all the time, anywhere, automatically. The third pillar is that it's pulled automatically. So you have no more surprise. The idea is that you're going to have automated systems in your Kubernetes environment that will say, oh, my current declared state is this, like it needs to be blue. But in Git, for the past 5 seconds, it's supposed that the humans want my system to be green. So I detect a conflict, I detect a difference. I go grab in Git what the new state should be, so green in my example, and then I deploy it automatically. So since it's automated, It's completely repeatable. It's highly efficient. Okay, no human errors in the loop. And the fourth pillar, it needs to be continuously reconciled, which is key for reliability. So the idea is that in Git, I declare I want my system green. The systems detect that, automatically deploy it onto my Kubernetes cluster. If there is a problem and human mangles and change some configuration to make some changes, I know that within the next minutes or hours, the automated system will kick in automatically and pull back from the source of truth, the Git, and apply it again. So you know your system are reliable, and the one place to do the change, which is version, tracked, immutable, etc., is the Git repository. So that's the philosophy and approach. And that unlocks, we're going to see more detail, excellent collaboration, even at very large scale, and really rock solid reliability because all the systems are applied automatically and reconciled automatically. So when it comes to modern API operations, what does it look like? The first one is our declarative approach. Obviously, we reuse the Kubernetes declarative approach, which is CRDs, custom resource definitions. So basically, we define some API-related constructs like an API, like an API collections, like an API rate limits, and all other constructs we need at the API level. So we define those CRDs, which in a nutshell teach Kubernetes about what APIs are, what they expect, how they behave. And from those custom resource definitions, we can declare custom resources. But as you can see, a small example on the screen, it's short, human readable, sweet. That's an example of a rate limit. That's what's stored in Git, and that's what any human can read, understand, and collaborate on. And we will talk more about that. The other part, since it's CRDs stored in Git that drive your overall API management solution, it's fully editable and version control. So you can see those CRDs look like this at that time. Then we had a change done by that guy at that time for such and such reasons, and all the changes are tracked and timestamped. So when it comes to audits, you know the current state of all your environment now, because that's the current source of truth in Git, which is automatically deployed, and you come back in time to see what happens by whom, when, and why. The third aspect is we talked about the declarative approach, especially the CRDs, enabling automated checks. So we developed checkers that checks for two things. First, it checks for errors because we designed the CRDs. We teach APIs to Kubernetes. We know how they're structured, how they work. So when you write your configuration, we can tell you, hey, there's a problem. You declare an API get tickets, which this specification and the services behind it is going to be hosted over there, but we don't see the services over there, so it's broken, or other kinds of problem like that. The second aspect is the impact. As you can define many things, many configuration, we will summarize all this. So in the example here, it's a rate limit. I really say, given all your configuration, this is what it will look like. These people, these application will have this much access to these APIs. And then the human can say, okay, that's really what I want. Let me move on. Or, oh, there is a problem. Let me change stuff. And once it's human discussed, human approved, the automated checks kicks in and everything seems fine. Sorry. These changes are committed, approved, good to be deployed, and then they're deployed automatically. So here we can see a screenshot of a monitoring / observability view where you can see some health metrics about the APIs. And we bring in context which changes were human approved and deployed automatically. So when you see a change in health, performance, behavior, or usage of the APIs, you can relate back, you can correlate to any changes that was made anywhere by anyone. And so all of that, the idea is to minimize the risk of breaking changes going to QA staging production. But if it happens anyway, then you can roll back pretty easily and come back in a working state in seconds, minutes. Um, the image I often take, it's like a Windows laptop, a gaming laptop. So if you're in that world, the traditional way is you have your laptop, you install Windows, you install your driver, you install your game, and all of a sudden you have a blue screen of death. What do you do? Option one, I erase everything, I reinstall everything, quite heavy. Option two, I come back from a backup, then I need to redo all the steps and update my drivers and start the game again with the patches to be able to work again. Whereas in the declarative world, in the Git world, all you have to do is to say, okay, I made a change 30 seconds ago. I can immediately see some problems. Let me undo and come back to the states I was 30 seconds ago. That's the whole philosophy. So, what does that bring? What does that change for you in terms of operational benefits? Uh, you can see on the left hand side about all the configuration, settings, who can access what, how much, etc., etc. And then your run part, your deployment in your actual production environment. There's a clear separation of concern between the two, and Git being the single source of truth in the middle, where every change should land into, and every application in your production environment or even QA staging environment is pulled from. So that's the single source of truth, which is always up to date. Because if anything in your system is different from Git, the system will automatically take the source from Git and reply it again. Okay. The second key benefit is all about transparency and auditability. So not only in Git can you discuss between humans about things, but you have the code at the same time, and you can comment each and every word of the code of the CRDs, the configurations, and that completely makes things transparent, because sometimes there can be misunderstanding, but if you have the code right there and you comment on the code, most of those misunderstanding goes away. Oh, I thought you meant it should be round, but I see in your code you meant it should be square, right? And since every change is versioned, time-stamped, and can't be changed after the fact, you can trace back any change anytime and understand what the flow, what the reasoning, what the reasons were. Obviously, in GitOps, you have very strong RBAC, so you can control who can change what when. Um, and it's a huge helper for all the risk reduction. So we mentioned one, the process minimizes the risk of breaking changes going into production, because you have human in the loop with transparent discussions in context of the code. You have some automated checks. But if problems happen in production anyway, you have the magic undo button, the rollback, as we discussed. Okay. So now time for a demo. So the demo will cover four aspects. The first aspect will be about, obviously, Traefik Hub product. How does it help you better manage API change management? How to change your API configuration while minimizing the risk of errors and problems. Then we're going to talk about API incident mitigation. So the idea is, if I have problems falling through the cracks and going in production, how can I deal with it and come back to a working state pretty quickly? Then we're going to talk about incident resolution. So not only do I want to come back quickly and effectively to working state, I want to understand and troubleshoot the problems of the changes I wanted to make. What went wrong? What should I do about it? And then we're going to talk about API observability, whether it's about health, usage, what's happening with my APIs, what's going on. So Emmanuel, the floor is yours.
Yes, thank you, Evan. So before we dive deep, let's see the architecture behind this demo. I have a Kubernetes cluster running on this laptop locally. Everything that we will see is local. I have Flux deployed, which is a GitOps tool. In place of Flux, any other GitOps tools, for example, Argo CD, could be run. Now I have Flux. It's connected to a GitHub repository. Every change we will make will be committed there, and Flux will make sure to reconcile this to the local cluster. Flux also applies some services to the cluster which are exposed as APIs, and all the other resources managed by Traefik Hub, like API rate limits and so on. It also installs the Traefik Hub agent, which cares for routing the traffic coming to the cluster, monitoring it, securing it, and this is the main component which handles everything. So before we dive deep into Git, let's see a quick tour of the Hub UI. This is the central control plane where we can see everything applied to all our clusters. But do not forget, everything is still managed from Git. What we can see here is a control plane where you can control everything, see who can access what and such. Let's start our tour at the cluster agent menu. I have different clusters, different agents connected. This one is the one running on my laptop. Here I can see, for example, which APIs are exposed by this agent. I can see all the details, all the configuration connected to it. I can see on the UI all the rate limits configured, all the users, which I have a few for testing purposes, some groups these users belong to, and I can also see the portals. I exposed the developer portals where we can see the documentation of these APIs. Let's check, for example, this one, which is the local one. Let's sign in with a test user. I have a Keycloak instance connected right now, but you can configure Okta or use Traefik Hub's internal identity provider. And here is the portal. This one displays the OpenAPI specification exposed by the APIs. If it's versioned, you can select which version you want to see. You can configure authentication to try out these APIs on the fly. You can add tokens, API keys, and I already did some for the demonstration purposes. And this portal is open source, fully tweakable. You can change the look and feel of it completely as you want. But I think right now it's enough of the UIs. Let's switch to Git, and let's see our first use case of API change management. What we will see here is that I will make some changes to an API. I will make it sure that it's faulty, and we will see that our linter catches it and prevents the merge. So let's edit this API specification, the employee API, and I will make an apparent typo, modify the service this API is connected to something that does not exist in the cluster. Let's create a new pull request. And currently, some GitHub action is configured, some GitHub runners taking up the change. You can see it's queued, and it will right now it's in progress, running the checks in the background, and it's running the static analyzer of Traefik Hub that understands the CRDs. And here we can see it has failed. One of the checks has failed. Let's see what the error was. And here in context, we can see that the analyzer cached. This service does not exist in the cluster. It prevents the merge, so you can correct it. So this is one aspect how the linter works. It can stop errors reaching production before it would cause an outage, for example. But there is also another use case of the linter. So let's go back and make some other change to this API. Oops. And right now, what I will do is make some changes to the rate limits of this API. I will introduce some big differences to this API that will have some effects on the cluster. Let's commit this as well. Create the pull request. the GitHub action takes up, the analyzer will be running. We will see what is going on shortly. And this use case is showcasing that since the analyzer has the full semantic knowledge of the CRDs, it can output for you some human readable report of what is the change causing. For example, the rate limit will be changed to this value. It will affect this group on these APIs, and probably I was not even aware that my change would affect this much APIs and this many users, and this would help the human reviewer to decide if they want to merge this change or not. So it puts the whole change into context. So let's decide to merge this request. There were no errors, so we can merge it. And right now, in the background, Flux is taking up this change and deploys it to the cluster. So we've seen the first two use cases of the linter. Let's switch to the dashboard, and here we will see an OpenTelemetry based dashboard implemented in Grafana. And while Flux does its deployment, let's observe this. Here we provided some example dashboards, what's possible as a base to provide your own custom dashboards based on this. But we can see here some errors, some error rates per API, some latencies, some request counts hitting all these APIs. We can even drill down. Let's see some other APIs who uses this API. What are the error rates of this specific API? If this API is versioned, I can even see the whole aggregated statistics analytics of this API, or just drill down to one version and see that. Or if the API is used by more users, I can see the drill down of these users. So here I clicked on one, so I can see who consumes which APIs by how much rate, if they have error experience and such. So let's go back to the dashboard, the main dashboard, and here we can see some vertical lines appear. The red one is the actual GitHub pull request that was merged. Here in the annotation, we can see the pull request reference, so I can go there, I can observe what was changed and by who and such. And the blue mark this displays that Flux took up this change and deployed it to the cluster. And if we observe these dashboards, these charts, here we can see our change caused some drastic changes. For example, here in the error rate spiked up because even though it was correct, but effectively the consumption is being blocked for some of these APIs for some users. So there is a huge error rate, almost 100%. And here we can see the latency also went down because now it's very quick to send back the error request, so the API does not need actual serving. So right now there is a production incident, and for example, I'm an operations person. I observe, oh, something has changed, and there is an incident. I want to mitigate this, go back to normal state. I can see which pull request caused it. It's very close, probably this was it. So I go back to this pull request and just hit the revert button to go back to the previous state. And this is the second main use case of API management with GitOps, that you can roll back easily with just one click to the previous working state. The action runs again. Yeah, we can see the change, who will be affected by how much, and let's decide to merge this. Okay, so it's merged. If we go back to the dashboard, we can see that there was another pull request merged. Now it's being processed also by Flux. And if you wait a bit, we will be able to see confirmation, because there are some load generators are running in the background. So we will see shortly that the serving of these APIs are restored back to normal. Yes, here we can see the error rate going down, latency starting to spike back to the previous normal state. So yes, here we can see, as Grafana updates the dashboard, that now we mitigated this production incident, we quickly restored production, and now the third use case is incident resolution. And incident resolution differs from incident mitigation by that now you have the time to resolve the actual issue, because what we did here is just reverted back to the previous one, but we don't know the root cause, what caused the error. Now the development team has time to investigate. If it was the error was in the application itself, they can provide a fix, they can test it, and then they can go and commit the changes again. And since everything is versioned in Git, you can even apply the previous faulty state to another cluster and see that what went wrong. You have no time to resolve the issue. And then after everything is done, you create a new pull request, and there you go. So since we are looking at the Grafana dashboard, let's talk about a bit about our fourth use case, the observability. Now what you can see is powered by OpenTelemetry metrics. We provide a standard way for metrics. You can use the toolings, what you have, what you know, it's your APIs, your metrics, you are free. We are not forcing you anything else, but of course we provide some dashboards. You can find it on Grafana Cloud, but these ones which I'm showing. But also, since we provide this in a standard way, you can correlate all the changes from all your stack, so you have end-to-end visibility, and this based on the standards. You have other tools, all the whole OpenTelemetry ecosystem you can utilize for your benefit. And I also have here in the background, hovering this Grafana dashboard, Prometheus instance. This is the latest release candidate from Prometheus. But if you, for example, not allowed to use a release candidate version in production, you can use the OpenTelemetry collector, which can filter, alter your metrics. You can make changes, transformations. You can drop metrics what you do not need. You can enrich them by any other source, and this way you can feed also not only Grafana but other tools as well. If you are interested in deeper which metrics we provide, here in the documentation of Traefik Hub, you can see all the details of it, which metrics and labels we provide. Labels are also called dimensions in other terms. These provide all the drill down capabilities that for a metric you can have a deeper understanding what is going on. And we also provide all the metrics for API management, and we provide more than 15 labels and more than 20 API management metrics, and also some ingress level metrics, since Traefik Hub is built on Traefik Proxy. So you will find all the information there. And I think now, to conclude, you have seen how efficient it is to do API management with Git, how easy it is to roll back, how easy it is to mitigate issues, incidents, and this is why I think that GitOps for API management is a game changer to day-to operations. So I give back the slide to Erwan.
Thanks, Emmanuel. Very clear demo. So I hope it was clear to you. Our goal was to make it real. So a bit more about the product. We said in terms of philosophy, we believed in the declarative approach that unlocks GitOps collaboration and all the benefits. And so quick words about the Traefik Hub CRDs, custom resource definitions, what the standard mechanism we use to teach, between quotes, API to Kubernetes. So with our CRDs, you can do everything. You can declare your APIs. What are they? What's their standards? Where do they point to? So in the example you can see on screen, it's not within Kubernetes. It's calling an external API. Some people use it to manage and control third-party APIs for internal use. Then you can group your APIs into collections like backend, front-end, or by topic, or whatever you see fit, based on the standard mechanism of Kubernetes labels and selectors. You can also create your access policies, who can access what. You can define your rate limits, how much, for which amount of time, in a very flexible way. API versions with many, many mechanisms. So there are, when you call an APIs, there are many ways in the URL, in the header, in the media tags and stuff like that. We support all of them, and you can even combine them in the same API versions. You can say, hey, I've got some developers that want to use a different URL. Oh, but I've got another set of developers who want to access it with a header, and I want another group of developers who want to access another way. No problem. You can have one API with one version accessed through all the ways. You can specify all that. Obviously, you can configure your API gateways, what will be the public URL or private one people will go to make the API calls and who can access what, etc. So implementing all the check, being the gatekeepers. And finally, your API developer portals, which are, so the way we deliver API developer portals, I believe is interesting. We deliver them as APIs, on top of which we developed an open source example you can find, which is public. So you can take it, you can tweak it, you can extend it to your liking and adapting to your needs. Or you can start from scratch from the API if you're building something for legacy solutions like portlets or whatever your needs are, okay? The second aspect beyond being declarative through a standard Kubernetes mechanism of CRD is all the checks. So we talked about the linters, both about catching errors, like for instance, the underlying service behind an API does not exist. You made a typo, please fix it. To the right-hand side, to what's the impact? You've changed many things. This is what it looks like. Is it really what you want? Yes, no. And the third pillar, Emmanuel discussed about all the observability, whether it's about health or usage. We expose everything in a standard way using open telemetry. So you can put it all together, as he explained, with your infrastructure, services, libraries, even cloud platforms. And you can have a single place with all your telemetry across all your technology stacks. And you can do that in open source tools like Grafana, but if you're into Datadog, they can ingest open telemetry. If you're into Dynatrace, same. AppDynamics, pick and choose. And within open telemetry, you have mechanics to collect the data once in a standard format and then send it anywhere you want in different tools depending on your team's needs, whether you're a security team, operation teams, level 4 support, or security teams, you can do great things. So we do believe in standard approaches. So let's step back and talk about the architecture. How Hub is structured, what does it look like? So we do have a SaaS central control plane, okay? And then we have the data plane where we install what we call Hub agents that act as the API gateway in your clusters, okay? So if your underlying services serving the APIs are within the cluster, we make your life easier and safer because we auto-detect all these services and there's no typo and wrong name, wrong whatever. When there are changes, we detect them and we adapt. But as you can see on the right-hand side here, even though the API management engine is a modern Kubernetes GitOps enabled approach, it can manage an API anywhere. So it can be APIs exposing applications and services on bare metals, VMs, or other legacy environments, right? If you can expose them as URL, we can turn them into API and unlock the power of GitOps to manage them, to have really modern and cool operations. Let's step further back from the architecture, about more the philosophy, what I call the architecture. So I covered that in the beginning of the webinar about the philosophy, the story and pains we heard, the needs and wants from our community. So the first decision was we wanted it to be Kubernetes native, not only because we believe in Kubernetes, but we believe in the philosophy: do one thing, do it right, be composable, be lightweight, scale horizontally, right? So to do that, we said, yeah, so we need to be fully declarative. What's the standard Kubernetes way, CRDs? Then it's all about GitOps. We discussed that at length, right? And those hub agents acting as your API gateways and ingress controller can be an all-in-one, can be deployed anywhere, right? So we're talking data centers, cloud, and edge. And what do you get for that? What are the high-level use cases? What are the biggest benefits we witnessed so far? So we covered that in the demos. It's all about change management, a new way to work to minimize the risk of introducing breaking changes. That is done through the Git pull request process, where humans have a place to discuss in context of the code for full clarity, version control, etc., etc. Once we have and collaborate at scale, right? You can think of Linux and other environments. The other aspect we discussed was about API incidents, right? If I've got a problem, the magical undo button, I roll back and I come back immediately to a working state. All I've lost is the changes, the new stuff I wanted to introduce. But then since it's declarative, I can take those custom resources, apply it the next morning, the next day, or right now, if it's really urgent, onto another environment. So my production is back on its feet working and serving my APIs. But now in parallel, I can very easily reproduce the same environment and dig down and understand what's going on, and then tweak it and improve it to redeploy it again in production. And the third pillar, it's all about governance, which was a founding problem when we discussed. APIs usage go up the roof for good reasons. Teams are getting bigger, more distributed. We need a solid, proven way to have a unique source of truth, to know anytime what the system in production looks like, what are the settings and configuration. And we need to be able to have absolute transparency on the health and performance and usage. So that's all the observe and secure. So what's the takeaway for you? Why are we talking about that? Where you believe we know, based on the initial feedback, where we know you will benefit. As you can see, it's a different mindset, a different approach, and a different tooling from clicking in UIs and doing custom scripting. GitOps really unlocks efficient operations, and it has been proven over and over for the infrastructure, apps, and services groups and operations. Gartner recently named GitOps as an early stage technology that will reach plateau in 2 to 5 years. That's really quick. So they believe it's going to be mainstream in 2 to 5 years. The net benefits for you, it's all about improving your SLAs and SLIs, right? You avoid breaking changes, you minimize them, and if you have some, you can roll back to working state immediately. The other side benefits is, since we are entirely based on standards, CRDs, sorry, open telemetry, we're reusing what most teams are used to and know already, right? So in terms of the time to value, to discover the environment, to being productive with it, is really, really short. Sorry. So what you see on the right-hand side is we'll soon publish an ROI calculator where you can enter how many APIs, your team size, your deployment frequency. And based on the DORA metrics from Google, the DORA is an institute that looks at DevOps and the benefits, the economics benefits of DevOps. And we applied the same metrics they've seen around the globe to APIs. So to give you a guidance on how the economics of your API operations could change with the GitOps approach. So soon on our website. And we have first feedback like this large German retailer that basically told us we're saving them hundreds of man days a year. So when you talk about product directions, obviously we want to do many things and many topics, but the core line we want to follow in the future. We want to keep focus on API change management. We believe there's way more to be done there to make it even stronger and more automated. We'll keep focus on API incident management to give you more context, more information when you need to troubleshoot. And thirdly, we'll continue to invest on that centralized API governance aspect because we see too many customers struggling with that and having that source of truth always up to date you can trust. And obviously security comes in. Thanks for joining. Very happy to spend that hour with you. Hope it was clear and looking forward to talking with you soon. Cheers.
Cheers, see you next time.